This lamp came from this lamp, which in itself came from this lamp. Years ago, I made a project that combined a clock and a lamp. This project failed for many reasons, but I really enjoyed how the lamp turned on and off. As a result, I took this project apart and made the second lamp you saw, which my kids love. I've decided to make one for them to enjoy. Lately, I've really been trying to make form just as important as function. I've decided that I want my projects to actually look like pieces of furniture that won't be out of place if they're sitting in my living room. The core of this new project is this lamp layer designed in AutoCAD. The idea is that you print these off for however many LEDs you want in your strip, and then you glue these layers together after you've sent them to the 3D printer. All of these layers join together, have little pass-throughs for LED strips, and make the top part of the lamp. Once the lamp layers have printed off, you can thread the LED strips through them. It's important to pay attention to the orientation of the LED strips to make sure that the signal can pass from one strip to the next. The LEDs being used here are a 5-volt RGBW type. They work perfectly with the Adafruit library for driving them. I went with 5-volt LEDs, so I didn't have to have a separate voltage regulator to drive the LED strip. The stem of the lamp is made from 1/2-inch copper pipe from a plumbing supply store. It fits into the base, and this is glued onto the bottom of the lamp layer. To make the project needlessly complicated, I decided to go with a beveled box for the bottom of the lamp. You can find these tables for calculating the angles that you'll need online. When you have that done, you set up your miter gauge and cut the boxes to size. You'll end up with a tapered box that's wider at the top than the bottom. Then you cut the tops to a 45 degrees so the top piece can slide in nicely. Find the center where you need to drill a hole for the potentiometer. You start at the corners where the lines cross, that's the center of the board. You use a small marker drill bit to drill a hole that will tell you where you have to drill the Forstner bit through. Once the Forstner bit is drilled, let you fit the pot in there. Then you go on the other side and you drill with a larger drill bit to pass through, and all of that will allow you to have the potentiometer to fit inside a piece of 3/4 inch plywood. After the base is done, you can cut the stem to length. I use a pipe cutter from a plumbing supply store. You basically just tighten this onto your copper pipe and then spin it around the copper pipe, and it'll cut right through in a nice straight line. The wiring for this project is fairly simple. First, you need to take the positive and bring it over to the potentiometer. I went with a switched pot here because I wanted the nice meaty click that you used to get from the old stereos when you turned it on. Once you've had that hooked up, there's a switch on the bottom and you have to hook it to the positive side of the pot. Next, you also want to provide the positive power to your Arduino, which is the microcontroller in use here. And then finally, you want to have the positive be brought down to the LED strip as well. Once you've got your positives hooked up, you can take this other line from the switch and bring it into the Arduino so the Arduino will know when the switch has been activated and turn the lights on. Then you start with the negatives and you bring that over, and you have to bring the negative to the potentiometer. bring the negative to the Arduino. And you need to bring the negative to your LED strip as well. After those are hooked up, the only thing left that you need to hook up is the variable resistor from the potentiometer to the Arduino, so you can have it change how quickly the lights will change. And then you need to have a line running from the Arduino to the LED strip to send the signal to there. This is the wiring hooked up to the power line in and the potentiometer. One thing I forgot to mention in the wiring diagram is that you're going to have a pull down resistor coming off your neutral to the switched side of the pot so it doesn't give any false positives. Now the only thing left is to attach the lampshade to your lamp. I bought a lampshade at a big box store and I've taken it apart here. I cut it down to size and then I glue it onto the lamp layers that the 3D printer made. It makes it quite a nice shade and fits really well. There you have it. I hope you enjoyed the video. Links to the 3D printer files and the code will be below.